Okay, this is the very end of section 3.2, and we're talking about precipitation. So we can predict whether a precipitate will form by comparing QSP and KSP. So here's what we're doing. Compare QSP and KSP. But this is the first time that Q ever comes up in this class. And so we need to talk about Q. Q is generally called the reaction quotient. More helpful, Q is what we get when we put non-equilibrium concentrations into the equilibrium expression. So here's how Q and K are related. If QSP is less than KSP, the reaction is going to shift to the right. And there will not be a precipitate because in this solubility reaction, you have a solid, right? This is the reaction. You have a solid becoming aqueous. And so when QSP is smaller than K, if the reaction shifts to the right, it favors the dissolved ions. Now here's how I generally think about Q and K. I like to put it in terms of a number line. So here's a number line, and so it goes on and on. So here's 0, here's 1, here's 2, and it goes on infinitely in either direction. So let's take these numbers out, and I'm just going to generically go bigger, smaller. So if QSP is less than KSP, so let's say that QSP is here and KSP is here. Here we see that here's 0, here's Q, here's K. Q is clearly less than K. The reaction will shift right. And here's the way I think about it. Here's Q, and Q always wants to be K. And so it's going to shift right. Just like over here in the reaction, it's going to shift to the right. And so when Q is less than K, the reaction shifts to the right. It favors the products. That's something worth writing down. It favors the products, which in the solubility product mindset means dissolved, not a precipitate. The second thing, if QSP is greater than KSP, the reaction shifts to the left and it will form precipitate. So we have, here's the solid, here's the dissolved or the aqueous. And so when Q is greater than K, the reaction shifts left and it will form precipitate. So we're shifting left, that's favoring the reactants or the solid version. So again, let's put it on a number line. So here's 0. And we know that Q is greater than K. So we'll say here's Q and here's K. And remember, Q always wants to go towards K. Q wants to go here, it wants to be K. And so it has to go left on the number line, which means the reaction goes to the left, which means it favors the reactants, which in this case is a solid, which means it forms a precipitate. And so that's the background of Q and K. So looking at example 4, we're given some information. We have 500 milliliters solution of calcium chloride. And the chloride ion concentration, so Cl minus concentration, is 8.0 times 10 to the minus 6 molar. And we're going to add this to a second solution, and this solution is 300 milliliters, and we know the concentration for this one, 0.0040 molar, and this is silver nitrate, AgNO3. Will the precipitate form when equilibrium is reached? So we are adding these two things together. This is what it says. So we're going to add the calcium chloride to the silver nitrate. So we've got an equilibrium reaction, and we want to know, is there a precipitate? They also give us the KSP, silver chloride, and it is 1.6 times 10 to the minus 10. So this is the basis of the reaction, and we want to know if there's a precipitate. But here's what we're really looking at. We have Cl minus and silver, and we're looking for a solid here. The KSP implies a dissociation reaction. And so the KSP is for this reaction here. In order for us to find Q, we have to know a couple of things first. We need to know the concentration of silver, and we need to know the concentration of the chloride. So the concentration of the silver, we have to take into account the fact that we had this concentration and volume of silver, and then we added it to another solution. And so this is going to be something that follows this formula. This is your dilution formula, changing the concentration of volume. So we know the original concentration of the silver, it's 0.004. We know the original volume, it was 300. We do not know the new concentration, and that's what we're looking for. And we know the total volume of the solution afterwards. There was 300, then we added 500, and now it's 800. And so what we're going to do for these is rearrange this formula and then plug in our numbers. So for the silver, the original concentration was 0.0040 molar, and the original volume was 300 milliliters. The final volume is 300 plus 500, 800 milliliters. And so milliliters will cancel out, and it leaves us with units of molarity, and we find 0.0015 molar. For the Cl minus, we knew the original Cl minus concentration. This is concentration 1, or M1. And so we'll put that here. 8 times 10 to the negative 6 molar. And that was 500 milliliters. And then we added 300 milliliters to that. The new volume of solution is 800 milliliters. Milliliters cancels. It leaves us with units of molarity. And we find a new concentration, 5.0 times 10 to the minus 6 molar. So we want to know, is a precipitate going to form when these two things are combined? And so we need to look at Q. And Q is really the equilibrium expression using numbers when we're not at equilibrium. So the equilibrium expression would be KSP equals concentration of silver times the concentration of chloride. The QSP is the concentration of silver times the concentration of chloride. The only thing is we are not at equilibrium, and here we are at equilibrium. And so all we have to do is plug in these non-equilibrium numbers to find Q. 0.0015 molar. Actually, we'll leave off the units because Q will not have units. Neither does K. And 5 times 10 to the minus 6th. So we see that Q equals 7.5 times 10 to the negative 9. So we see that Q is greater than K. And you can use a number line if you want. I generally do, just so I don't mess it up in my head. So Q is greater than K. So here's K, and here's Q. Q is always trying to get to where K is. And so this says that we are moving left. The reaction is going to shift left. And when this reaction shifts to the left, we are favoring the solid, which means a precipitate forms.